We've talked about some of the characteristics of waves earlier, like amplitude, wavelength. We've talked about frequency, period, and velocity, and today we're going to delve a little bit more deeply into the relationship between frequency, period, and velocity. So first of all, we have to define those things. So period is the time it takes to complete one cycle. So one cycle of a transverse wave would be starting from rest, up, down, back to rest. Crest, trough, back to rest. Okay, that would be one cycle. So the time it takes for one cycle like that to be completed is the period. Period, T, is time divided by cycles. Okay, and this is measured in seconds. Okay, and the reason it's T and not P is because it's basically just measuring time. Okay, so this is period, and it's in seconds. Okay, frequency is measuring pretty much the same thing, it's just flipped upside down. So frequency is the number of cycles completed in 1 second. So period was how long does it take to complete one cycle, and frequency is how many cycles can you complete in 1 second. So for frequency, F, that's equal to cycles, or number of cycles, divided by time. Okay, and the frequency is measured in cycles per second, but that has a special name, that's hertz. So this is frequency, and it is measured in hertz, Hz. This is how period of a wave would be measured. So let's make this thing oscillate. It's creating waves at a certain frequency. Now we're going to take a timer, and I'm going to try and time this thing to see how long it takes for a single wave to be created. Okay, and so notice this green dot here. When it touches the play button 2 times in a row, that would be one wave being created. So here we go. Ready, set, go. Ooh, about 0.68 seconds. So that would be the period of this wave, the amount of time it takes to create 2 crests. The frequency is the number of cycles in 1 second. So if I would be able to time exactly 1 second and then count how many cycles that was, that would give me the frequency. So here we go. Oh, pretty close. Now, I couldn't count how many cycles were happening during that 1 second, but this down here tells me that it's creating 1.5 cycles per second. 1.5 cycles per second. And if we look at the timer that we had before, 0.68 seconds, if we're doing number of cycles per 1 second, we can use that 0.68 seconds to figure out what the frequency would be, the measured frequency. So if I do 1 divided by 0.68, that gets me 1.47 hertz. Pretty close my timing was. So the frequency is the number of cycles that can happen during this 1 second. Now the relationship between period and frequency is that they are reciprocals of each other. Notice, period is time divided by cycles, and frequency is cycles divided by time. So they're the same 2 variables, the same 2 measurements, it's just that they are flipped over. So period is 1 over frequency, and frequency is 1 over period. Now let's do a couple quick examples here. A radio wave has a frequency of 100 megahertz. What is the period of this wave? If it tells us the frequency, we can figure out the period because they are reciprocals of each other. Now it says that the frequency is 100 megahertz. And this mega means 10 to the power of 6. Okay, so when we're figuring out the period, It's 1 over the frequency, which is 1 over 100 times 10 to the 6. And 1 over 100 times 10 to the 6 is 1 times 10 to the negative 8. 1 times 10 to the negative 8 seconds. The second example, a pendulum completes 30 cycles in 15 seconds. Calculate its frequency and period. Frequency. So it tells us the number of cycles that were completed, and it tells us the amount of time that passed. So in this version, we're going to use frequency equals cycles divided by time. And our number of cycles is 30. Our number of seconds is 15. And so we end up with 2 hertz, which is 2 cycles per second. Now, when we're figuring out the period, we can either start over and go time divided by cycles, or we can do the reciprocal of this. Either way, whether you do 15 divided by 30 or 1 over frequency, you're still going to get 1 over 2. That's seconds, or half a second, 0.5. Now we're going to relate frequency or period to speed. Okay, so how fast a wave is traveling depends on how quickly it's moving up and down, or shifting back and forth, depending on if it's a longitudinal wave or a transverse wave. Okay, so let's remember that something's speed is the distance it travels divided by the time that it takes to do that. So we can adjust that formula for dealing with a wave. Okay, so speed is distance divided by time. Now we can connect our speed formula to its relative parts of a wave. So speed is distance divided by time. The distance part of a wave is its wavelength. Wavelength looks like this. It's the Greek letter lambda. There's a way to draw it fancier than that, but I think that we should stick with something simple. So it's wavelength, that's the distance part, divided by time. And the time part of a wave would be the period. So the speed is the wavelength divided by the period. Let's just write this in. So that's wavelength. And this part is period. And this is speed. So we're not referring to it as velocity. We're not referring to it as a vector. We're going to simplify it a little bit and just say this is how fast it's moving. But let's not worry about direction. So this is speed. Now it's important that you match all of your units. So we typically measure speed in meters per second, which means that your wavelength needs to be measured in meters and your period needs to be measured in seconds. If you wanted to measure your speed in something else, you just have to make sure that your wavelength and your period match whatever speed you're working with. We can also change this formula to switch out period for frequency. So if you remember, period is 1 over frequency. And so when we change out the period for 1 over frequency, we get V equals frequency times wavelength. Okay, if we would put 1 over frequency over here, the wavelength divided by 1 divided by the frequency is equal to frequency times wavelength. That's called the wave equation. It relates speed to frequency, period, and wavelength. Now we're going to do another couple examples using the wave equation. The distance between successive crests in a series of water waves is 4 meters, and the crests travel 9 meters in 4.5 seconds. What is the frequency of the waves? So using this formula, using the wave equation, is pretty straightforward. What is more difficult is figuring out what exactly you're looking at in the question. So it says that the distance between successive crests is 4 meters. So let's just look at it like this. Okay, here's a crest, here's a crest. The distance between successive crests is 4 meters. Okay, that's telling you the wavelength, right? So it doesn't tell you the wavelength of this set of waves is 4 meters. It tells us that in a different way. So this is the wavelength, 4 meters. It also says the crests travel 9 meters in 4.5 seconds. So that's saying that this crest travels 9 meters in 4.5 seconds. So it's saying that this part of the wave is moving at a certain speed, right? This is its distance traveled, and this is the time it took to travel there. Okay, so we need to figure out the frequency using all of this stuff. So here's what was disguised in this question. It tells us distance and time, which gives us velocity, or speed in this case. So if we know speed and we know wavelength, then we can use the wave equation to solve for frequency. Okay, so here's our wave equation. Speed is frequency times wavelength. We know the wavelength. We don't know the speed in order to figure out the frequency, but we can figure that out separately. So speed is also distance divided by change in time, and that's 9 meters in 4.5 seconds. 9 divided by 4.5 is 2. That gives us 2 meters per second. So that's the speed that this wave is traveling. Now we can plug that into our formula here, but I'm going to rearrange it first. So if I want to get frequency by itself, it's multiplied to the wavelength, so I'll need to divide by wavelength. So V over lambda equals frequency. So that gives us 2 meters per second divided by 4 meters equals 1 over 2 hertz, or 0.5 if you like decimals. And the second one. The period of a radio wave from a radio station is 1.18 times 10 to the negative 3 seconds. What is its wavelength? So it tells us the period, how much time it takes for one wave to be formed. Now, in order to figure out its wavelength from the period, we also need to know the speed at which the wave is traveling. But the question doesn't tell us the speed. Well, it actually does, it just hides it. So here it says that this is a radio wave. And a radio wave is an electromagnetic wave. And electromagnetic waves all travel at the same speed, the speed of light. The speed of light, or c, is 3 times 10 to the 8 meters per second. So it does tell us the speed of this wave, it just doesn't come out with it really clearly. Okay, so be careful about that. So now we can figure out its wavelength using the wave equation that has period in it. Okay, so speed is wavelength divided by period. Now to get the wavelength by itself, I need to multiply by period, right? Because it's divided by period, so to get it by itself, I undo that. So now it's V times period equals the wavelength. And our speed is 3 times 10 to the 8 meters per second. Our period is 1.18 times 10 to the negative 3 seconds. That gives us the wavelength. And when you calculate that, you get 3.54 times 10 to the 5 meters.